able to reach or where we are lacking. So many things are there in front of us, very huge challenges. And these tools, definitely the remote sensing and GIS are the best tools to assess ourselves as well as to push ourselves towards the achieving the targets. So that way we are expecting a lot from you, Aarthi, to waiting to hear from you. And once again, I welcome you to this distinguished lecture series. And thanks to Dr. Arun Prasad to introducing Dr. Aarthi to us today, to all our students. And yeah, most welcome. Aarthi, welcome to you. Thank you.
Thank you so much, ma'am.
Thank you, ma'am.
Thank you so much.
I would just give a brief introduction about the speaker to all our participants, students, so that they get motivated and get a direction of how you've navigated to through your career. So Dr. Aarthi Aishwarya is at present a postdoctoral researcher, as you all know, but she did her bachelor's from Anna University and then master's in science on environment and geomagnetic engineering from Italy, then pursued her PhD from Indian Institute of Space Science and Technology, Thiruvananthapuram, and then moved to Sweden for her postdoctoral research. She is a recipient of Best Paper Award at International Conference on Energy and Environmental Resources and UNIVER Como School. She has also published extensively on the topics related to her research interest, which includes urban geoinformatics, climatic change analysis, and modeling using cellular automata and machine learning techniques. So with this background, I heartily welcome our speaker of the day, our chief guest, guest of honor, everything, Dr. Aarthi, to this webinar. It's a blessing that we are able to connect each other without even meeting personally. So this virtual platform has given us a chance for discussion, to be motivated, to get inspired, and to learn. So thank you so much, and welcome to the webinar or on Distinguished Lecture Series. Thank you.
Thank you, ma'am. Thank you, Sulochana, ma'am, and thank you, Dr. Aarthi. And very good afternoon to each and every one of you. Of course, they both have given a very vast background about my education and my research interest. So, of course, yes, I'm Aarthi. So, Aarthi Aishwarya. So, I would like to first of all thank all the faculty members and then the staff members of the Department of Geography, Central University of Tamil Nadu, for organizing these kind of webinars on distinguished lecture series. I'm very sure, ma'am, these kind of webinars would motivate and then enable students, and then they would provide a good platform to them where they get to interact and then meet various academicians, researchers, and then experts, and then they get updated in their area of research interest. And a special thanks to the head of the department, Professor Sulochana Shekhar ma'am, for giving me this opportunity to be a part of this distinguished lecture series. And of course, to all students and everyone present today for this webinar to listen to my the lecture. So, of course, I think Akriti has given a deep background of my educational details. So the topic for today's lecture will be significance of GIS and then remote sensing based techniques for achieving sustainable development goals. So my screen is shared now. So sorry, just a second. Okay, so yes. So I need not go back again into my educational background. Enough has been said. So basically, I make use of GIS and then remote sensing technique for monitoring environmental processes more related to urban impact of urbanization on climate change analysis, and then the circular economy in the solid waste management in developing countries, and then energy efficiency. So it's a kind of interdisciplinary research I'm working on, and then these are all my broad research interests. So today for this lecture, what I will be talking about is just what are all SDGs, that is in short the Sustainable Development Goals are called in short, SDGs. And then why do we actually need them, and how GIS and remote sensing, in short, RS, could be helpful in achieving these SDGs, and then what is the current state of the goal of these sustainable development goals, and then what would be the future scope. So I'll be discussing about all these things in this lecture. I'll be covering up all these things. So first of all, we have heard, and then we would have mentioned even in our research interest this about the sustainable development goals. I'm very sure most of you would have heard of this term, but just to highlight and just to emphasize, this is nothing but the goals, 17 goals set by the United Nations in the year 2015 to have a better, sustainable, and then livable world by the year 2030 with 17 goals. So the main aim is to have the needs and aspirations of the present without compromising the ability of the future generations. That is, whatever the technological developments or advancements we aim to target to achieve the 17 goals in the future should not affect the present generations. So this is in short about the SDGs. Okay, so now we know SDGs, and there are 17 goals which they have set to be achieved at least by 2030. So at least we have 8 more years. So why do we actually need them? So just to have a background about these SDGs, before these SDGs, UN has set Millennium Development Goals in 2000 with 8 major goals. So even though the MDG, that is MD, the Millennium Development Goals were successful, based on the lessons and then the achievements which we have got, so the UN has set new targets, that is the Sustainable Development Goals in 2015. So even though the Millennium Development Goals were successful, there were certain sectors which were still not achieved, or I would say still under progress, or we are still yet to achieve them. So the first and foremost is the poverty. So though we can say very positively that we have eradicated poverty in most of the countries, there are certain countries, especially in underdeveloped economic countries, where poverty is really a huge crisis. So we are still yet to eradicate poverty. And then the second thing is, of course, we are getting more digitized, and then advancements in technologies, and then innovations and so many stuffs. So because of all these things, what happens is the environment is getting degraded, and then we are depleting our natural resources. So these anthropogenic activities, that is human induced activities, they are depleting our natural resources. Ultimately it causes climatic changes, which is of very huge concern recently. And then the third thing is inequality, be it within our country and then among different nations. This inequality is getting increased every time we make progress into the science and innovations. Because when a country develops, then we compete with other countries. We have developing, and then we have underdeveloped, and then undermost developed, and all those stuffs. And even within the countries, so even within the nations, we have inequalities in terms of when we go for an employment, we have this gender and then age restrictions, and then so on. So we have inequalities in every sectors. So this inequality is getting increased because of all these science and technologies. And then because of this, governance is becoming very complex, because we have to tackle all these information, and then we have to ultimately we reach all these 17 goals. So governance, that is managing all these stuff, is getting very complex. So for a sustainable development goal to be achieved, I would say there are mainly 3 major pillars, that is the environment, the social, and then economic. So we cannot just have an environmental development without having a social and an economic balance. The same way, so we have to have a balance between these 3. So when a society, when a country is aiming for sustainable development, it should have an environmental growth, and then the societal growth, and then ultimately the economic growth also. So these are all the needs for SDGs. And as I just mentioned, we have 17 goals. Though there are 17 different goals, they are not all, I would say, it's dependent. They are all dependent in the sense, though they are 17 different goals, each one of these goals are interlinked. So, say for example, if you want to reduce the poverty, then we have to look into this the agricultural maps, because we have to take into account of the food production and so on. So all these goals are interlinked. So we have 17 goals and then they are all interlinked. So obviously it is a multi-actor process because stakeholders and then decision makers from all the different aspects, say for example, environmentalists and then policy makers and then decision makers and then economists from every various field has to take into action. So it is a multi-actor process. Say for example, the sustainable development goal, let's say it's 11, it aims at having a smart cities. So when we talk about smart cities, we cannot just say digitization of your infrastructure and then having everything digitized. It's not only that, because when we target a smart city, we should have a good infrastructure, the transportation system, and then the environmental degradation we have to take into account of them. It should have a less pollution. So every factor, the social, economic, and then the societal factors takes into account. So we have to bring in all the actors, multi actors into this process. So in basically, I would like to emphasize that SDGs, they are 17 goals, but they are not separate goals. They're interconnected, and then it involves stakeholders' participation from various fields, and thus it is a kind of a complex one. We cannot deal it within single aspect. It has to be taken with all these three factors together. So what is the current scenario of the data we have for the sustainable development goals? Okay, so I said there are 17 goals. Of course, for 17 goals, we have 169 targets. That is, we have to, each goal is divided into number of targets and then indicators. That is, whether a goal has been reached or not is measured in terms of indicators. So basically, it is a huge data set, right? So we have 17 goals and then 230 indicators. So it's a huge data set. So what is the current scenario? First of all, the data which we have, at least for these developing and then the underdeveloped nations, they are not fully available. And even if the data is available, they are not dynamic. In the sense, we do not have timely data, current present data. We have data, maybe a decade old data, or for sometimes we do not have data at all. And the data quality is poor. So they are not validated, we have some missing information, or they are not currently updated. So the data quality is not poor and it is not usable. So even if they are usable, if it of good quality, the data sharing is always a problem. You have to get special access and then permission and everything. And some people, just for some sake, they are not ready to share their data. So the data is not accessible. And even if everything goes good, if the data is of good quality, it's of dynamic, and then it is shareable, people are not making use of them in an efficient way. So even though there are science and technologies available, when we ultimately get the data, due to the technological advancements are not present in developed and then underdeveloped and then developing countries, those data are not used effectively. So I would like to here emphasize that globally around 230 million children born under the age of 5, they are not registered in their countries, the statistical system. So they do not have information on this child, the records, and also mainly on the poverty, because poverty is the number one goal of the SDGs, which we are planning to eradicate at least by 2030, because which was not possible in the MDGs also. But still, 77 countries still now they lack the information of their poverty in their countries. So we could say ultimately there is a shortage or lackage of data, at least in the of course even in the developed countries, but more effectively in the underdeveloped and then developing countries. So this data collection or revolution is very, very important for sustainable development goals, because as I just mentioned, the Millennium Development Goals was not able to be achieved effectively because of the lack of geospatial information. So as I just mentioned in the first slide, we have this economic, social, and then the environmental processes for a sustainable development program, and they are all interconnected, and then they are spatial, inherently spatial. Say for example, even within a same district, within the same taluk, we would say the environmental problem occurring in one region is not the same as in the other region. It varies, right? Because it varies from region to region. Even within a taluk level or a district level, it varies. So the data, whatever data we are going to have, it should be location specific and then time specific. And all these are interconnected. So the UN has recognized that there is a need for geospatial information and other related analysis to make sure that we reach the sustainable development goals at least by 2030. And most important thing is, without this location attribute, whatever data we are going to collect or whatever data we share is not going to be useful. Let's say, because I'm just sharing a Excel sheet with you all, it's an A spatial data set. I have everything data. Say, for example, let's say the water quality. So I give you the composition from the location, I mean, without the location details, the composition, the chemical composition, at which level, depth of the water table and everything, but without the location details. You cannot make use of the data because you never know globally at what scale and then at which country or which district I have taken this data. So without the locational details, even though you have a very vast information of any information of a geographical phenomenon, you cannot make use of the data. That's very obvious, right? So that's the need of the hour. For sustainable development of any region, for any community to happen, we need data that is very dynamic, and then it is location based, and then it is specific, and then to the current, I mean, at least to the current community. So I would like to emphasize here again that location is the very, very important dimension for decision making. So just to give you an example, let's say we are planning to have an automobile industry located. You are planning to set up an automobile industry. So what are the factors we will look into? So first thing would come into your mind is where I have to set up, right? Then you decide about, okay, what would be my revenue, why I have to set up there, and then what would be the when I would be inaugurating them, and then what are all the pros and cons of setting up the industries. So, but basically, the first thing you would like to know is where, because even when you make your research, so what is the thing you will be saying? Okay, what is your study region? Where you want to make your analysis? Because within that study region, you are going to make the analysis. So without that, you cannot have that. Okay, I'm going to make an analysis. Okay, that's fine, but you have to restrict yourself to a particular study region. So the location factor is very, very important. So this is the very crucial point of making geospatial analysis into the sustainable development goals. So now we have these three techniques, that is big data, because obviously it's a 17 goals with huge number of indicators, and then multi-actor process, and then we have to have the stakeholders information from various fields. So it's obviously a big data and then complex data, and it's obviously non-linear and so on. So we have the advanced GIS techniques and then remote sensing based techniques. So let's see how these three techniques could be useful in achieving the SDGs. And of course, we all are from the geography background, so I need not go in deep about what is GIS and then remote sensing and so on. But just to have a highlight, so GIS is a computer-based system for mapping, visualizing, and then making any kind of spatial analysis for the geographical phenomenon. And then we get high resolution temporal satellite imageries making use of remote sensing techniques. So that could be used for any environmental monitoring purposes. So how these GIS and then remote sensing could help in achieving the SDGs. So especially it would be more useful in the agricultural field, in the food production, and then clean water, and then energy, and then industries, ultimately trying to mitigate the climate change effect. So let's see at least a few of them. So when I talk about the food and then agricultural sector, because nowadays there is I think most of you would have heard of this term, precision agriculture. So making use of advanced satellite informations and then GIS techniques in the agricultural field, because making use of that, you can analyze what kind of crop would be best suitable for your region, and then how the irrigation system could be modified for betterment, and then you can predict what kind of phenomenon, natural phenomenon, disaster could happen in that region, so that you can have various type of agricultural techniques like drip irrigation and drought irrigation and so on. So basically, you are integrating science with the traditional agricultural practices, and then you are improving, or you are improvising, or effectively you are bringing up the agricultural sector in a higher way. So when we relate this with this poverty map, say for example, in underdeveloped countries where we did not have access to all these informations, when we have the satellite images, when we relate all these two, then we can identify, okay, these are all the regions where the poverty level is very high, then in these regions, what kind of crop could be cultivated, at least to meet their needs. So this way, even in underdeveloped or in regions where we do not have access to this information, this remote sensing technique could be useful. And then, of course, the policymakers could make a decision based on the maps which we are going to produce out of the GIS techniques. And nowadays, increase in urbanization and development in industries. So what happens ultimately? We are all clearing up the vegetation lands, the forests, and then the basically the green space to accommodate the increasing populations. So basically, we are losing up all our, the vegetation cover. So this is just an one example. So when we have the NDVI maps, I'm sure again, so you all must be knowing the normalized difference vegetation cover. So one good example or one good advantage of having remote sensing based satellite imagery is that you can know what was the condition in the past and then what is the condition present, and then you can make predictions or stimulations what could be uh, uh, the scenario in the future. So say for example, then you can make kind of analysis, and then the policymakers or authorities can take decisions based upon, okay, these are all the areas where we are losing up the vegetation cover a lot, and then stringent actions or policies could be taken based upon that. So this is one great advantage of making the temporal satellite imageries. And when we talk about the smart cities, just I explained a couple of slides before. So for a city to be smart, we just do not just require a digitized map within the infrastructure and so on. So everything has to be in an efficient way. Say, for example, it should have a proper road infrastructure, and then the industry setting up, it should have less environmental impacts on the vegetation, on the water bodies, and so on. So, and then if there is any hotspots, let's say the government is going to propose an industry or an education institute or anything for that matter. So that if we know the hotspots of the region, then we can plan. So any city which is planned will have a comparatively lesser negative impact on the environment rather than unplanned city. So you can plan depending upon what kind of growth is happening in your city. So what could be the best infrastructure system I can provide to the city so that it does not, or at least it would have a minimum impact on the environment. So this is another one example of GIS and then remote sensing. And oil spill monitoring. Yes, one of the, I would say, the major impact of human-induced activities on the ocean environment, oil spills. You all must be aware. So when we transport the oils across the seas, so because of this oil spill, not only the salinity of the ocean or the sea, they get affected, the aquatic organisms, and then the environmental stuff of the ocean gets affected. So nowadays we have high resolution imageries, sentinels, and then radar based systems where you can you can monitor what is the reason behind all these things, and then basically the anthropogenic, that is human induced activities, and then you can monitor when was the last one incident happened and then how it could be prevented. So this is very useful when it comes to oil spill monitoring, making use of radar, remote sensing, and so on. And one another thing is water quality maps. Say, for example, when you have the water quality, what is the chemical composition of the water present in a region, and then whether it is from the tube well source or something. So you have the water hardness map of a region, and then that could be even related to your disease map. Say, for example, because of this waterborne diseases, dengue, and so on stuff. So you can relate this disease maps with this water hardness map, and then relate, okay, whether is there any relation between these two maps, then the health authorities, they can decide upon taking an action. And even recently now in this corona situation, so we have this maps, so you can even Google them and then see, okay, so what is the statistics of my present district or city? So you know where is the maximum hotspot. So remedies or quick action can be taken into those regions. So in this way, it would be, because basically rather than giving statistical information, when information is given in the form of maps, So it would be very easier and then convenient, and then it could make sense, and then appropriate action could be taken, and all the regions that are in the vulnerability could be at least prevented from having the next impact. And that's what is mentioned is environmental hazard mapping. Say, for example, in any disaster situation, there are four main cycles we would say. So that is the mitigation, the preparedness, and response, and then recovery. Of course, the environmental hazards, it could be landslides, earthquakes, they are not preventable. At least we can mitigate to some extent to avoid having them. So even if it happens, we should be prepared in a situation to handle them, and then how quickly we come back and then recover from that one is very important. So when we have this environmental hazard mapping, say for example, these are all the areas prone to landslides, these are all the areas prone to soil erosion, and then so on. So then we can have a kind of prepared situation. So even in the worst case disaster situation happens, the authorities, the planning, the governance can take quick action, and then at least to reduce the impact of these natural hazards on the environment and on the people. So this is one another example of GIS and remote sensing. And another one is affordable and clean energy, because again it's a very hot research topic nowadays, that is urban heat islands. Because of the increase in the urbanization, the rural cities are comparatively less hot than the urban cities. So we have this urban heat island pattern found mostly in the cities. So that is related to, in some countries, most of the mortality rates are increasing because of this increase in temperature. So we can even relate this UHI maps to this mortality rate, and then identify what are all the causal factors affecting these UHI. And also, as we were just discussing in the beginning of the lecture, nowadays the world is targeting to go for fossil free fuel. So rather they are going for replacing with solar energy, hydrothermal, biomass, and so on. So when you have the thermal imaging of a building, which we usually get from thermal bands or the satellite imageries, we know where are all the areas of the buildings where you have high energy loss. So these maps could be used to create a spatial interaction model, that is whether the change in land use land cover maps or the increase in the urban heat intensity has induced the higher energy efficiency in the models, and accordingly whether any mitigation measures or the uh, the building reformation and stuffs, so restoration, so anything that should be going on, and then policymakers will make this decision upon having the insurance. So those stuffs are related to this one. So we can predict what would be the electricity consumption, the energy consumption of my building in the future, so that because nowadays in most of the developed countries, so we have this carbon tax. So because if your industry is going to emit more than this permissible carbon, or consume more electricity in your home for your appliances, then your rental charges or your the government-based taxes will be higher for you. So based on that, the regulations, if we have the for the be it for residential or for industrial purposes, then people might get awareness, and then they might reduce the use of electricity, or at least to have at least another solar energy and so on. So this is currently a research that is being widely done, at least in the developed countries right now. And so again, so we have the suitability maps, because be it for any industry setting up, or for any, let's say, if you want to locate a region for, let's say, a landfill, let's say. So we make use of various factors, right? Because it should be away from a water body, it should be away from school recreation centers. Then we make use of all these maps in GIS environment, and then we select a good or suitable regions, we would say. So all these would be possible only with this making use of geospatial data, and then making use of GIS analysis. And ultimately, why do we do all these analysis is we would like to know what would be the impact of all our environmental, all our activities on the environmental processes. Ultimately, we want to reduce this climate change, or, because of all these environmental, the industrial developments, and then the innovations we are taking up. Ultimately, it is degrading our environment, leading to change in climate. So ultimately, we should have a map visualizing what would be the impact of each of our activities on the climate, so that we can identify those regions which are vulnerable to climate changes. So that's in a way we can target to achieve the 17 sustainable goals. So in this context, GIS and remote sensing play a major role because we collect information from various disciplinaries, and then we have it in a digital format, and then we analyze them, and then we make spatial analysis out of them, and then we make scenario-based analysis, and then we provide such, recommendations or suggestions to the policymakers. Hence, based on that, appropriate decisions could be taken in the right way. So, one potential advantage of having GIS is, of course, we represent the real world in a digital form. So, though, say for example, the transportation, the road networks, and then the buildings, the urban areas, though they look as a different layer, they're all interconnected. So, geography, you cannot just say geography is just dealing with maps. It is about actually intellectually connecting things which are actually connected, but in real world scenario, nobody looks at them. So we are trying to connect digitally, of course, each of these layers, because we see all of them as layers, right? Because road network is one layer, and then urban layer is another one. And also one main thing is, when you want to make a decision out of that one, you cannot just let it happen in real world and then you cannot make a decision. Let's say example, okay, my area, a particular region is growing in terms of urbanization, and then in an uncontrollable way, let's say. So you cannot let the process go on for years and years, and then you cannot wait to see what would be the consequence. So rather, as a GIS or an expert or a researcher, what we could do is, okay, so this is the urban condition of my region presently, and then these are all the plans proposed by the community or by the government to have a planned urbanization. So we make scenario based analysis, sensitivity analysis. What if I follow this government proposed law, and then what if I include all these infrastructures, what would be the urban growth in the future? So we create several scenarios, and then based on the one which has minimum impact and then it is useful for the community, then we select one, and then we present it on to the municipal authorities, to whomever the local governing agencies. Then they make changes in their policies or retain their policies. So this is one advantage, because where you can have scenario based analysis, and then you can you can impact that, you can provide that into your real world situation. Otherwise you cannot have it run in the long term, and then you cannot just wait for the process to happen and then take decision later. So this is one major impact of having GIS into a decision making stuff. So to put it in a nutshell, so GIS and then remote sensing, how it could be useful for SDGs. So we gather the geographic information, that is the location based information, and then we could visualize them as layers, various layers, data layers, and then we make this spatial analysis. We conduct different types of advanced spatial analysis techniques, and we can, based on the sensitivity analysis which I just explained, we can choose the most appropriate one suitable for the community, and then based on the regulations set by the government, and then we have to make into action. So this is very important. So finally, what is the stuff is, when we have the remote sensing and then GIS, you can collect data for any extent, for any spatial variation, and then the potential and the limitation of that particular region's natural resources can be accessed, which is very, very important and then vital for any planning strategy. And then one important advantage is that the temporal data set, and then the continuous monitoring, because nowadays even you can have an hourly data set in terms of weather monitoring, or a day's data set, monthly or yearly, depending upon the type of environmental scenario you're planning to monitor. So depending upon that, you have various time scales of the data set at regular intervals. And also, even in a region where you do not have access to data collection, so remote sensing technique, it's very obvious, and it's a very basic advantage of having remote sensing. You can have data in those inaccessible region also. So these are all very important, because a continuous data set, a temporal data, I mean, a time-based data set, and then location-specific data set is very, very essential for any decision to be taken, be it for any environmental monitoring purposes, and it is very, very crucial for the government and then the policymakers, and that is possible only if we make use of GIS and then remote sensing. So now we know that for sustainable development goals, we have 17 ones. So again, I'm highlighting that it's a huge data set, and then GIS and then remote sensing could contribute in providing these continuous temporal data sets. So now the third part of our technology is big data, that is artificial intelligence. So this is nothing but a machine learning technique, and in which we have this artificial intelligence, and then we all are aware, and then we use artificial network knowingly or unknowingly in every day-to-day activities of ours. So it's nothing but training and then validating the computers, the machines to think like humans, to help and then augment our human activities. So it is, of course, it's not as simple as I'm just explaining right now, but to be in a basic way, this is what is AI looks like. So AI, as I just mentioned, we are making use of it in mobility services everywhere, starting from airspaces and then even in our cars in which we drive, we have this location-based services. And also, let's say for example, we visit a nearby restaurants or a shopping mall, because nowadays we have mobile phones. So based on after we return from the place, we get location-based services, because based upon your research, I mean recent visit or search, we would like to recommend. So all these are AIs, and even in medical industries and then energy supply. So for example, I was just mentioning, so you can make predictions out of what would be your energy consumption in the future. And then waste treatment, it is very, again, a crucial research topic, because of course in developed countries the landfills are not permitted, but of course in our developing countries and underdeveloped countries it's still permitting, but they are going towards zero landfill scenario, that is towards circular economy. So the AI will be very, very useful in terms of having, how would be the lifespan of the existing landfill could be extended, or how to have different anaerobic digestion or incineration techniques and so on to reach the circular economy concepts. So you have machine learning into them. And then agriculture sector, as I just mentioned, the precision agriculture stuff. So where you integrate GIS and then remote sensing and then the big data, that is the neural networks into your stuff to predict what would be the best crop could be cultivated to your region and so on. And industries, of course, most of the industries are now automated. So with the advancements in this science and techniques, where machines are taking up of the human labors. So these are all the applications of some of AI. So it is reported that at least 3/4 of the SDGs, that is 79% of the goals of the SDGs, could be achieved when we implement artificial intelligence into them. And of course, AIs, as I just mentioned, they have the potential and then the ability to take up all these SDG goals. So I would like to highlight again here that there are three major pillars, that is the society, environment, and the society, environment, and then the for all the for the pillar, as a pillar of SDGs. So when it comes to the societal outcomes, how AI could be useful. Say for example, again the same stuff. When we have the poverty maps, then we can relate that to the agricultural map stuffs, and then we can try to eliminate at least the poverty at the underdeveloped countries by providing information saying that this could be the best agricultural crop you can provide and so on. And then the quality of education, because this could be well related to the current situation during this pandemic. We were all, most of them were working from home, and then we are taking up the lectures, everything online. So this is one of the best examples where we make use of technologies and then we continued our educational or our tutorial processes without any lagging or so on. And also the clean water, and then the sanitation, as I just mentioned, and then the energy, and then the sustainable cities and then communities. In all of these, AI may play a major role. And economic, yeah, sorry, this I was not able to recollect at that time. Yes, so because when you have machines, the automated machines into your economics, say for example, people working in very hazardous or chemical, high exposure to chemical industries, so those people could be replaced with machines so they can have a good, decent work environment. And also, when we have highly automated machineries into the system, then of course, we are leading towards the industrialization and then innovation and reduce inequalities. Because, say, for example, uh, people working in the solid waste management or scavengers or sanitary workers. So when machines take up their work, then they will have improved quality of working, and then this would reduce inequalities in their work environment. And environmental outcomes, obviously, all these are targeted towards mitigating the climate change and then to provide a better life, be it on the land and then below the water also. So even though AIs have a good advantage or potential advantage of helping or augmenting this GIS and then remote sensing, as I just said, 79% of the goals could be achieved with this AIs. Still, there are certain negative impacts. As we are all aware, any technology has its both plus and then minus, that is the pros and cons. And then it is ultimately up to us how we take up and then how we manage or how we balance between these two. Any technology has its, as I just said, the advantage and the disadvantage. It is up to us how we make use of this advantage and then we provide a better outcome out of them. So when it comes to AI, what would be the major disadvantage? So I would like to highlight, some of them. So energy footprint. So when we talk about AI, we talk about computers, machineries, right? So we need obviously huge computing, high computing performance systems, so which require high cooling efficiencies, and of course the energy requirement for them would be high. And also nowadays they make use of cryptocurrencies, that is the digital currencies like in bitcoins. So they make use of high electricity. So it is predicted that when we make use of more technology based services, so the energy consumption would be higher. Of course, the environmental aspects would be lesser, the impact would be lesser, but then the energy consumption would be increased by 20%, and this would again impact the environment because we would be depending upon more for the electricity consumption. So this is one of the major impacts of having the automated stuffs into our technology. And biased, because AI is nothing but we make machines to think like humans. So it's nothing but we humans are training them. So there could be bias in everything, starting from algorithm, because one user or one expert could be familiar or expertise in one particular algorithm. So he might be training AI in that particular algorithm. And then whatever kind of the measurement and then whatever the sample size, everything is biased because it's up to them, and then it's specific to the data set and then specific to the region. So all these mixed together, we call it as uncertainty into a model. So that is very, very innovatable. So that's again a biased AI. And then inequality. Though I said that if you have this automated machines, the work life of the workers working in that one could be improved. It will impose inequality in the sense people working in the region of A only will have a higher salary and then they will be more preferred, and then others might not have or might not be provided with the same salary. So there will be an income imparity everywhere. So these are all the certain AI's shortcomings. So ultimately, I would say there are 17 goals, and then with this GIS and then remote sensing integrated with the artificial intelligence, we would be able to at least achieve 12 goals. So starting from the poverty and then health, education, and then better water, energy, and sustainable cities, and then marine and ecosystem. So we will be able to achieve directly at least 12 sustainable goals out of 17 with this integration of GIS and then remote sensing. So what would be the scope of these two techniques? Of course, as I just mentioned, we have risk and opportunity in any field. So same with this GIS and then remote sensing. So it is up to us to make use of only the opportunity of these three techniques and then avoid having the risk whenever the decision making situation arises. And then since it involves huge data and then more precisely location specific data, clear rules should be set when we share the data and then the data security and everything, because breaching the data breaching and then misuse of data could happen when there is always a the transfer of data happens. So strict and stringent action should be taken when we have this data security issues. And of course, most of the researchers, people working in this field should be aware that geospatial techniques are capable of solving these sustainable development goals, because even we as researchers, students, we should be always relating. I would say that whenever we do a research, we should be relating, okay, this is the research, and then in what way it could I could relate my research to the sustainable development goals. So in this way, our research does not exist. I mean, that does not end up just with completing a thesis or a PhD thesis or just a paperwork submitting for a manuscript. No. As I just mentioned, it is to achieve the sustainable development goal. It is the responsibility and it is the requirement of each and every one of us to contribute to our community. So be it in a small scale research or a large scale research or in any level of the research. So always kindly refer your research to any of these sustainable development goals. It could be any region, and then try to see how it could be useful to your community, even at a small scale, district level or national level, how it could contribute, and then how it could be beneficial to your community. So first we have to recognize that these geospatial techniques are capable of solving these SDGs, and we have to bring in all the societal initiatives. Say, for example, as I mentioned, it is a combination of different stakeholders. So when a project is being handled, we have to think how the stakeholders from industry should be benefited, how the stakeholders from the government policymakers would be benefited, how a common person living in my community would be benefited out of them. So a research, if you are able to, if your research is able to answer all these questions, then I think it is obviously a better outcome would be expected out of research. And geospatial techniques are, of course, they are cutting technologies, in a sense they are existing, and it is our responsibility, duty to make use of them in an effective way, in an efficient way, so that we all stand together to make this sustainable development goals achievable at least by 2030. It doesn't mean that we have to wait till 2030 to happen, because we are already we have only 8 more years to achieve them. So we have to make a strong resolution of having that. Okay, so at least in my community, in my research area, I'm going to contribute at least a little to the sustainable development goals. And of course, so it's a big data set, it's targeted at a global level. So integration of the regional level and then global data set is very essential. Okay, I have the data set, and then he has collected a data set from a particular district. So when you combine, then you get for a particular state. So this integration should always happen, of course, with the data restrictions when you share the privacy policies and with all these stuffs included. And of course, so you have to get all the stakeholders involved into this one. So maybe these kind of workshops or feedback sessions, or just creating awareness among the public, because most of them, they do not even know what is SDGs. So we can create awareness among them to what is happening in their community and what they feel is good, very good for their situation, and how they can bring, even if they are literates or illiterates, they might be having some idea about what is the common environmental problem occurring in their region. So we could get involved, make them involved in all these feedback sessions, so that everyone in the community plays a major role into this sustainable development goals. So I would like to thank you all for this lecture, for listening to this lecture. And I always like to highlight the fact that the world which we are currently living in is, of course, is not our own. We have borrowed that from a future generation. So it is our primemost duty to deliver or to give back to them in a better and then sustainable way, so that they can preserve and then carry on this legacy, at least to their next future generation. Thank you so much.
Thank you. Thank you so much. It was such a useful, informative, yet very colorful presentation. I mean,
Sorry, because I was a bit out of breath because due to my medical condition, so I was not able to deliver in between, good effective manner.
but very impressively made slides and beautiful presentations.
Thank you so much.
Um, may I invite the participants if they have any questions, anything to ask?
Yes, yeah, I forgot to mention that one. So if they have any questions, I'll be very happy to answer them. And then, in fact, I expect questions. Yeah.
So, anyone, please, from the participants? Scholars?
It could be any question, or it could be any even basic information you would like to hear from me, or any research topic related to this one you would like to know in detail. It could be anything, not even questions. It could be any queries. It could be any feedbacks on at least on how the lecture series was. It was good. It was bad. It was okay. So something, anything. It could be anything, not just restricted to questions. You are open to, anything.
Hello, can you hear me?
Yes, yes, please.
I particularly focus on goal 3, health and well-being.
Mm-hmm.
Asking the question how to minimize the ecological fallacy.
Sorry, how to
It's a
minimize
very big
ecology?
challenge in ecological fallacy.
Okay.
When I
Yes, go ahead.
that is my question, because when I suppose I have collected some data at village level,
Mm-hmm.
some data at individual level, and interpret and whole village level. So
Okay.
there is probably chances to ecological fallacy. So how can I minimize this?
No, may I get your question clear? So you mean to say you have let's say a disease map of a particular village. So you mean to say how you want to minimize the hello?
Ecological fallacy. Yes.
Yeah, your voice was a bit not clear. So, yeah. So what kind of question? I mean, what was the type of question you were asking? So you have the disease map of a particular village, how it would reduce to have the environmental impact on the particular village. That's what your question is, right?
Yes, ma'am. Can you hear me?
Yeah, okay, but your voice is it's not very clear. Okay, anyway, I got your question. So, okay, so you have a disease maps. I'm not sure what kind of disease. So let's say it's of any of the disease. So you have a disease map of a particular village. So it could be of anything, as I just said. It could be of, say, for example, a waterborne disease, or it could be maybe depending upon the location of the village, whether it is located to an industrial area. So, effluence from the industry is affecting the people of a particular disease, because especially people living in the standing industries, they are very much prone to certain diseases. Or it could be the water degradation because of the the high chemical composition present in this water. So it could be of any of any region. So that's the main point which I was highlighting. Probably I did not much highlight that one. So when you have the disease map, so what we do is we map all the infrastructural facilities of that region. Say, for example, the number of industries, what kind of industries. So we have the industries based upon the pollutions, four categories: the green, white, orange, and then red industries. So depending upon the pollution factors, so we map them, and then we try to relate if these diseases are related to this orange and then the red categories industries. So if not for industries, what is the air quality level, or whether it is related to I'm not sure because of the disease, again I'm saying, so whether it is because of this increase in urbanization, because in the nearby regions, because when a village is located in the peri-urban cities, so it is more prone to, because of this urbanization, it might have happened because of this increase in surface temperature. So whether it's because of the loss in vegetation. So you have to look into what kind of disease, or it could be a waterborne disease, or any kind of disease. So first you have to look into what is the occurrence. So that's what I said. So you have to have at least a decadal old data set of the region, the land use, land cover, and how it has rated, and then you have to always interlink. And then interlink what is the factor, influencing factor, what could be the factor that has aggravated or it is causing this disease, and then we have to make analysis based on that one. So as I just mentioned, you cannot just have an environmental aspect of the city and then we cannot target. So it has to be all together. So of course it's a disease map, you said, that's right. So we have to make into account of all other factors and then see which is the one most dominating or most influencing, and then we can make decision out of that one. So I hope I have answered your question. If it is not clear, you can please ask me again.
Hello.
Hello.
I have two questions.
Yes, sure.
First one, I would like to ask whether the installation of solar panels in cities, will it reduce the UHI effect or will it escalate it? Like when we find the hotspots of areas having higher temperature and we plan to put solar panels there, so whether in the future it will reduce the UHI or LST over there, or will it escalate it? And second question I would like to ask, how can I correlate UHI with health, like using GIS and remote sensing?
Okay, so to answer your first question, so LST is nothing but how the surface is emitting back your radiations, which is emitted from the satellite sensors, right? So it's basically the reflective, the EMR radiations back to the. So it depends upon various factors. At what time the image was taken, and the sun's inclination, and then the weather, whether it's a summer period, I mean the climate. So depending upon the season, so it depends upon so many factors. So solar installation panels, of course, yes. So based upon the reflective and then absorbing power, I mean the nature of the material used, so it's going to have an impact. But installation of solar panels will directly not reduce the impact of LST, because as I just mentioned, LST of course is a combined factor of all these things, how your vegetation, the input factors play into an effect. So to minimize LST, what the recommendations from based on the literature and then the research which I have undergone is, you can have green spaces all around your urban cities, urban regions, and then you can have green roofs. That's what they say. So you can see in cities they have green roofs, and then they call it as vegetations in their balcony and somewhere. So where you can have these vegetations, they act as kind of carbon sinks. So they absorb all this heat. So solar panel cannot directly reduce the impact of LST, because LST is a combination of all these factors. And for your second question, yes, how UHI is related to this mortality rate. Yes, especially in Western countries. So when they have extreme summers, extreme weather conditions. So because of high, and not only in Western countries, even in our country, India. So when we have, especially I think in Hyderabad and then Delhi, so when we have higher temperature in summer, more than even 40 degrees sometimes. So what happens is, there is an associated risk, especially with the young kids and then the older generation. The mortality rate is associated with this high heat. So we have already seen in articles in the newspapers related to this one. But there is a study relating how this UHI increase, increase in UHI is related to this mortality rate. And it has been established that people living in regions where the UHI, that is the urban, basically UHI is nothing but you have this heat emission from your surface is higher, so they are prone to get the longevity rate is very less. So again, as I said, you have to have the mortality statistics of those region, and then you have to map the UHI, and then you have to relate to them. So, okay, this is this factor, and then this in this region, what is the mortality rate, and is that directly related to that one? Of course, it is. Of course, it's not in a bigger scale level, but it is there is an associated direct link with this UHI and then the mortality rate. Yes.
Okay, I just have to ask one more thing.
Yes.
Like regarding like green spaces and green roofs, like
Mhm.
as you said that will be a solution for to reduce the LSD. So is there any studies or any way to do any suitability analysis, like to find which areas we can keep this green roof or green spaces, and can we analyze after keeping these things how the LSD will be reduced, like using any modeling, like is there any method for that
Yes.
to show that in the future?
In the sense, at least for a researcher point of view, we can make suggestions. But if you say suitability map, because when a city is planned, say for example a residential area is planned, there are certain factors or infrastructural facilities that has to be followed based upon the government's regulations. Say for example, a building should not be too close this much, and there should be a minimum open space, and then that's the reason in most of the cities now we have the parks, recreation centers, and then playgrounds in front of their apartments, so that there should be enough open space for a breathing at least stuff. And then when there is a the community parks and everything. But we as a researcher, you or I cannot make a suitability analysis and then say, of course, we can say that there should be a green space when you plan a city. There is a need for green space and then open centers, and then at least there should be a. I mean, nowadays they prefer to have regions, of course, not in countries, not in next to oceans, and then the water bodies. So there are facilities, but to reduce the impact of UHI, we cannot make a suitability analysis because that's the government regulation policies. When they plan or build a city, they have to provide certain recommendations. And then when you talk about rooftops, and I think that we can to some extent manage, because that's the reason, because when you have the high reflecting materials on your rooftops, then obviously your material is going to absorb lots of heat and then emit heat. So that's the reason sometimes they go with the rooftops, and then they keep vegetations, and then even for salinity purpose, and then also to reduce the impact of heat. But all these stuffs are a joint effect, I would say, to reduce to some extent the UHI. But this is not the only solution. But if you are interested, I can share with you some of the research that has been carried out right now. But to reduce the impact of UHI directly, these are all, I would say, a certain impact factors, I would say, but they are not the only solutions, and they are not the quick remedial solution, I would say, because it involves huge regulations, policies from the government, and then how located, not only because when we talk about UHI, not only the present, say for example, only those buildings characteristics affect. Say for example, the nearby feature, whether you have an agricultural land next to it, or it's an open land next to it, or whether it's located to a water body next to it, or it is away from an industry, because there's no point in having a rooftop and then next to an industry which is emitting high level of radiation. So there's no point, because obviously the neighborhood, the vicinity factor is going to affect your building. So there are so many factors that's going to affect UHI. So that's what I said. It should be a participation, and then community level stakeholders involvement. It should be there, and then only then, especially this UHI cannot be eliminated. Could be the effect could be minimized to a certain extent.
Thank you so much, man. Thank you so much.
Thank you.
I think we have Dr. Chitra from Department of Social Work. Am I right, ma'am? Hello?
Yes, hello, ma'am.
Yeah, there is Dr. Chitra has raised hand.
Yeah, sure, ma'am, please.
Ma'am, you have any question?
Yeah, hi, thank you. Sorry, my mic was mute. Yeah.
No problem, ma'am.
So glad to see you here. Ma'am is assistant professor at Department of Social Work at Central University of Tamil Nadu. Yes.
Okay, yeah, please, ma'am.
Yeah, my question to you is like how to access. See, I'm from a social science background, so I'm not technically aware about this satellite imaging and this remote sensing. So, how do we technically avail this data? How is it possible? Like my research scholar is currently working on um, uh, basically an agrarian study, and like if she would like to access satellite images of those, so how we can access it, what kind of technical support we can have. So yeah.
Okay, ma'am. First of all, your question itself makes me feel very happy because this is what is, at least I think, is the main target of these kind of webinars, because where we induce the awareness and then get people involved from other than these geography and then geology department. Thank you very much, ma'am, first of all, for the interest. So yes, depending upon the area and then what kind of data you're going to use, your research scholar is going to use. There are data available online for free that could be downloadable. Say, for example, from Earth Explorer from the USGS website. So probably I can share with you where you can, and there are other more websites where you can download the data for free. But if you want to go for high resolution or in particular in-depth details, there are certain, I mean, our Indian satellites where you can just pay a minimum amount and then you can purchase them. Of course, we have to go through the official the stuffs where you have to write to them why you want to make use of the data, for what purpose, commercial or for research purpose. They are data, and I think till the Sentinel data we have right now, the 10-meter resolution, I think it's more than sufficient for a research scholar. They can, depending upon again what kind of application, then what kind of city or what kind of the output he is going to work on that one. So I think we can have free access data is available and then it is always downloadable. So you have access to the data set, at least for Indian cities. Yeah.
Okay, thank you for that. I'd be grateful if you can share the links
Sure,
that
ma'am.
data can be which are freely downloadable. So,
Yes, sure, ma'am.
thank you.
And I think I have got one more question from the chat box, probably. No, that's all.
That's all, I think.
Yeah, Aarthi, just I want to ask you, not the question. What are
Yes.
the collaborative opportunities available? Maybe students exchange, faculty exchange, or any research collaboration with your university or anything, any other university from Sweden?
Yes, ma'am. Here, right now, our university has a PDF opportunity and then PhD opportunity also right now. I think the deadline is till this end of this month.
Okay.
It's a very good, yeah. And then it's a Swedish government funded project. It's for 8 million. Even into which I'm one of the applicants. So I think they are looking for a PhD for that one. So if anyone is interested in building energy and then the remote sensing and GIS, they can very well apply. I can just share the link with you, ma'am, so you can circulate among your students. And collaboration is always possible, but not only in this Linnaeus University. If they are interested, what kind of research field they are interested, because at least in Sweden, what they are actually looking for is remote sensing and GIS people, because they have this advanced techniques, but they are kind of lacking in people with GIS and remote sensing expertise. So probably our students from geography background or from any environmental science background, they can actively get involved and then get collaborated with any of the faculties. If they are interested, then yeah, you can I mean, recommend, or you can just let me know, ma'am, so I can.
Sure. Erasmus programs are there in university? Any scholars are there from India?
Not exactly, ma'am. So what is happening is we have a program for 5 years. So where PhD students from Nepal and even from Terry University and then Indian, I think one more university. So where they have this extent. So 2 years they will be doing their PhD in Sweden, and 3 years they will be doing in back in
Yeah.
India. So that's a fully funded one. So whenever they stay here in 2 years, they will be fully funded with stipend and everything. So that's a kind of just, I think, 2 months before they recently got this project, and then they are working on that one.
Any such
So
opportunities or any fellowships, please let us know. You can
sure,
send
ma'am.
through Arun or to us only.
Yeah, sure.
That will be helpful to
I
us.
can send it to both, Dr. Arun Prasad and Dr. Akriti, because I have the contact of both of them
Sure,
right
sure.
now. So
No
I
problem.
can send it to both of them. It
Thank
shouldn't
you.
be a problem.
Thank you, Aarthi. I think it's a very, very elaborative, very informative lecture. We all
Thank you
thoroughly
so much.
enjoyed, and I think SDGs, the most ambitious goals of this century. Yeah,
Yes,
let us see
exactly.
how far we are going to achieve it. Thank you so much for giving
Thank you.
this wonderful
Yeah,
lecture.
thank you so much for this opportunity, ma'am. Thank you so much.
Thank you. Yeah, over to Akriti.
Thank you, ma'am. Thank you, Dr. Aarthi. It has been a very nice discussion, I think. Most of the students must be motivated to find opportunities in Sweden. I saw a couple of our alumni also joined during the presentation time. So that's very nice to see. And also we have representation from social work department. We spoke to Chitra madam. So
Yeah.
that the success of the webinar is very much clearly. So
Yeah.
thank you so much. And now may I invite your friend and my colleague, Dr. Arun, to please give the vote of thanks. Yeah.
Thank you, madam. Thank you. Yeah, Dr. Sulochana madam, Dean, School of Health Sciences, dear faculty members, students, scholars. Thank you so much. It's indeed my pleasure to have been asked for posing the vote of thanks on this special occasion. My hearty thanks to you because you have accepted, in spite of your decision, you have accepted in a single call. So thank you so much for that, and you have delivered a very informative lecture. Hope many students and all of us have got a new insight into the application of GIS and remote sensing techniques for achieving the SDGs. So thank you so much for that, and thank you so much, dear participants, dear students, for spending your time. I think hopefully you all have got new insight into the subject. So thank you. Thank you so much.